Okay, this is Algebra 1.11, and what this is solving multi-step linear inequalities. And we're going to focus on how do I solve linear inequalities using more than 2 steps, and then how do I recognize a special solution to an inequality. So back to here for the 2 steps. This is just like your equations. We're going to solve these inequalities very, very similar to like what we're doing with the equations. But just to recap, remember when you multiply or divide by a negative, you need to reverse the sign. So that's really the main difference between inequalities and equations. So we're going to go ahead and solve this problem here. We have 3 times the quantity of 2a minus 1 is greater than or equal to 10a minus 11. So if this was just an equal sign, you would still distribute. So everything is still pretty much the same as if you were solving equations. So you're going to distribute. 3 times 2a is 6a. 3 times 1. Here's you guys a negative 1. Make sure you distribute to the next number too, that second number in there. Some of you are forgetting to do that. You're only doing it to one term. You need to do it to all the terms in the parentheses. So 3 times a negative 1 is a negative 3, and greater than or equal to 10a minus 11. So at this time, after you distribute, if there's any combining like terms that you can do on each side, then you would do that, but there's none. So now this is just like when we were solving equations. You want to do your variable terms to one side, constants to the other. Again, this can be done 4 different ways. I typically like to move the variable term first and the one that has the lower coefficient. That way, then your variable term is positive. But you can do it other ways. So negative 3 is greater than or equal to 4a minus 11. Since I moved the variable term to the right, I'm going to move the constant term to the left. Do not move everything to the same side. That's what some of you guys are doing and you're having errors. So be careful. So we're going to add 11. And then negative 3 plus 11 is 8. And 8 is greater than or equal to 4a. Now divide. Now here's where you got to be careful. This is a positive, so you don't have to worry about it. But if it was a negative, you're going to have to reverse the sign. Now 8 divided by 4 is 2. And 2 is greater than or equal to a. Well, I like to go ahead and rearrange that to where your variable is on the left. So I'm going to rewrite that as a is less than or equal to 2. It does say to solve and graph. So remember graphing. If you have to handwrite your graph, you just put the end number that you have here. I forgot what it's called for a second. But 2 and then 3 and 1. Now, this is a less than or equal to, so it's a closed circle. Then again, it's all the numbers less than, oops, I don't know what happened there, less than 2. Okay, again, some of you said, well, I'll just look at that arrow, and that sign, the inequality sign, will go the same direction as this one. That's true as long as your variable is on the left. The variable has to be on the left to do that, otherwise it's going to be opposite of that. Okay, so what we did here, you distributed, then you moved your variable terms. You moved your variable terms. Then we add or subtracted. This is now a 2-step equation. So you add or subtract. Then it became 1-step equation. And depending on what's going to happen, you multiply or divide. Okay. And then once you get finished with your equation or your inequality here, then you need to graph your solution. The difference between inequalities and equation is that you have a lot more numbers that will work to make that statement true. So we can't just say, okay, a is less than or equal to 2. We want to show that set too. So what this is doing, the number line is showing us all the possible solutions to that inequality. Okay. So then your examples, and so you may go ahead and solving these. So just same thing, variables to one side, constants to the other. So if you subtract that, so 2x is less than or equal to 8, right? And then divide by 2, I'm running out of room here. So 2x is less than or equal to 8. I'm going to erase that just because I'm going to run out of room. Divide by 2, x is less than or equal to 4. You don't have to do any changing of the sign because you're not dividing by a negative. So 4, 5, 3, open or close. I always go back and check. So I'm notorious for dropping my equal sign. So I always go back and check before I do anything. Okay, so that is a closed circle. And it's everything less than 4. Okay, now at this point, hopefully you're pausing and you're doing these. and not just sitting here and just watching me and copying what I'm doing. You need to be doing them too, just so you get that practice. Watch number 2. 2 can be tricky, so be careful. You have a 1x here, so that's x. Distribute a -3. Distribute a -3 to the 2, so that's a -6. Now you can combine like terms. This is on the same side. You have a 1x minus 3x. So this is a -2x. Be careful because I can see people messing that up. So -6 is greater than 4. Add 6, add 6. I'm going to run out of room. So -2x is greater than, not equal to, right? Greater than 10. Now divide by -2. Here's where you got to be careful. X is less than -5. X is less than -5. So we're going to have a -5, -6, -4. Watch how you do your number line. Now it's less than, so I want to make sure I didn't drop. So that's an open circle. And then all the numbers less than -5. Okay. Then we have -6x. So you have distributive on both sides. And then what I would do, you don't have to do it this way, but I'm going to add 6x because a -6 is lower than +2. And you have a -6 is less than 8x plus 10 minus 10. So you have a -16 is less than 8x. If you divide by 8, you're going to get a -2 is less than x. Now notice your x is on the right-hand side. I'm going to rewrite that, and x is greater than -2. So you have -2, -3, -1. Open circle, just double check. Yes, open circle. And remember, the open circle represents that -2 is not part of the solution set. If we put in -2 here, it would not be true. But if you put in a -1.99999999997, then yes, it'd be true. So this is what that is saying, is that -2 is not part of the solution set. All right, so you have 3x plus 3 plus 11 is less than -2x minus 26. Then we have 3x. This can be combined like terms. I would add 14, -2x plus minus 26. Sorry, I couldn't read my own writing. -26. Then add 2x, so that's going to be 5x plus 14 is less than -26. I'm going to jump down here. I'm going to subtract 14 from both sides. If I subtract 14, then that is going to be -14. That's going to be a -40. Divide by 5. That's going to be a -8. So x is less than -8. Make sure it's not equal to. Good. -8, -9, -7. So, and it's less than, so it's going that direction. Okay. So these are very, very similar to your equations. You just have to watch distributive. That's a problem some of you are having. But then also when you multiply or divide by a negative, don't forget to reverse the sign. Okay. So we have a word problem. And we're going to set up the inequality and we're going to solve it. You're going to bowl with friends and have at most $30 to spend. It costs $7 to rent shoes, which that's expensive, and $2 per game. At most, how many games can you play? Well, if you're right when you walk in, you're spending $7 on renting the shoes. You don't have to keep renting those over and over. You just rent them one time for the day that you're playing games. So $2 per game. So here's where I would say maybe G or whatever letter you want. That's the number of games. Always define your variable. What's it mean? So you have $2 for every game, at most $30. So that means I have to spend less than or equal to 30. Okay. Then you can solve it. -7, 2G. That's going to be 23. And when you divide by 2, that's going to be 11.5. But you're not going to go up and say, I want to bowl 11.5 games. They're going to look at you like, what? So you don't round up to 12. The most you can bowl and spend less than $30 is 11 games. So you got to think about your scenario and if you should round up or down, but you don't have enough money to bowl 12 games. You have enough money for 11 and a little left over. All right. Special cases of inequalities. This is just like when we were solving equations. We had identity or infinitely many solutions, and that's when a statement came out to be true. So for example, in this one, if it comes out like 2 is less than or equal to 2, 5 is less than 7. If it comes out true, then that's an identity. Well, this would be identity, but this would be an infinite many solutions. So it would be a true statement. Now, no solutions means it's a false statement. So 2 is less than 2. Well, that's false. 2 is not less than 2. 2 equals 2. So that would be a false statement. 5 is greater than 7. Well, that's false. 10 is greater than 20. That's false. So if it's a false statement, it would be no solutions. Now, remember, in the equations, in order to have these, what about the variable terms? The variable terms were exactly the same. But then the other numbers, it depends. Now this one, not only did the other numbers matter, but the sign matters. So I'll explain what that means here. We're going to do this example. We're going to do 2k. We're going to distribute 2k minus 10 is less than 2k plus 5. Well, you're going to distribute. Then notice, again, the variable terms. The variable terms are exact same on each side of the inequality after all the combining like terms, anything that can be done. So 2k minus 10 and 2k plus, or is less than 2k plus 5. Well, if we got rid of the 2k's, we have a negative 10 is less than positive 5, which I don't need to rate the positive. Is that true? Yes, that is a true statement. That's a true statement. So your answer, since this is true, your statement can be IMS, okay, infinitely many solutions. Now, let's talk about graphing. To graph that, what that means is every single number works. If you put in for k, distribute, every single number will make that statement true. So what you want to do there is, since you don't have really an endpoint here, or a target number, you can, I like to just do 0, 1, and -1. But for the infinitely many solutions, you're going to draw a line above it that goes in both directions. It's infinite. It can go forever in the positive, it can go forever in the negative. Every single number will work. So when you graph infinitely many solutions, that's how you want to graph it, right? So what we did here, we distributed, we moved the variables, the variable terms. Then you want to look, is it a true or false statement? Then you're going to answer IMS or no solution. And I'm going to tell you how we're going to graph a no solution. And I'm going to add a fifth one here, and then we're going to graph. So you're going to answer IMS. Don't say true or false. You're going to make sure you answer infinitely many solutions or no solution. Now to graph a no solution, I'm going to put that over here. No solution. To graph a no solution, you still want your number line, and you can do 0 and -1 and 1. But in order, I don't want you to think you forgot to graph it, so you're going to write n/a. Okay? So when it's a no solution, to graph it, put NA, and that means not applicable. You can't graph a no solution. There's no solution. Okay, let's try this. We're going to distribute. 6x plus 8 is greater than or equal to 6x plus 12. Right there, these two are the same. So that means if we cancel those, 8 is greater than or equal to 12. Well, is that true or false? That is false. So the answer is no solution. And then to graph it, you're going to do 0, 1, -1. You can put any numbers down here. It doesn't matter, as long as it's correct on the number line. And then write n/a, just so you don't think you forgot to graph it. All right, let's try this. -10 minus 12n is greater than 48 minus 12n. Okay, look at the variable terms. They are exactly the same. They're both -12n. Because if you added it, then they would go away. So you have a -10 is less than 48. Well, it's -10 degrees less than 48. Yes, a lot. So that's false. No, true. Sorry, lied. So that's true. And so this is an IMS. And you graph it, whichever three numbers you want. Just make sure that they make sense on the number line. Then you draw a line here above going both directions, saying that every single number is possible. Okay, so that's how you can tell with special cases of inequalities, and that's how you solve inequalities involving more than two steps, just like equations. Okay, so you guys, this concept is not that difficult. You can make a lot of errors, though. That's the problem. There's a lot of little places that you can make errors. It's a simple concept, but it can be one that can trip people up at times. So be watching that. Thank you.